Greetings everybody, my name is Jonathan Pierce. I am from Los Angeles Pacific University, and this is my final speech on how the human eye works. I have no financial binding in this speech. In the beginning, God said, "Let there be light," and it was. Amazingly enough, light is the very ingredient that we need to see. The very ingredient we need to have vision. In this speech, I will discuss how the human eye works. We will learn together the structure of the eye, the function of the human parts of the eye, and the common age-related eye diseases. The light that illuminates this room allows each of us to see clearly. Well, however, some of us may not see so clearly, but that is not because there is a lack of light, but rather a lack of visual functions. Your eyes are not what causes you to see. It is your brain. The eye receives objects as light waves and transmits these light waves into information to the brain. The light rays bounce off objects and eventually tell your brain that it is seeing an image. There are many parts of the eye that cause us to see. First, the eye is shaped as a globe. It is what we call the orbit. It is divided into two parts. The first part is known as the anterior chamber. This anterior chamber is only 1/3 of the entire globe. The second part, or the back part of the eye, is 2/3 of the entire globe. It is known as the posterior chamber. We will discuss both of these in light detail. The anterior segment, or chamber, is only 1/3 of the eye. The anterior chamber consists of the iris, the cornea, the lens, the ciliary body, and the aqueous humor. The posterior segment of the eye is the back portion of the eye, and I said this is 2/3 of the eye. Contains the vitreous humor, it contains the retina, it contains the macula, the optic nerve, and it contains the eye muscles. When we get to the eye muscles, we'll discuss that very, very briefly. There are many more parts of the eye. For the sake of this speech, we will leave that alone. The eye is much like a camera. If you've ever seen a camera, it works in a similar way. The front part of the camera, the anterior chamber, is the lens. Posterior chamber is where the film goes. That's what records what you see or take a picture of. Light is the main source. Without light, we have no vision. The anterior chamber is much like a camera. The posterior segment is like the film of a camera. Let's discuss this a little bit further. The first thing we must look at is the outer shell of the eye. This is what protects the eye. This is called the cornea. This is the very front of the anterior chamber. The cornea, how does this work? It reacts to light. When it receives light, it bends it just right so it goes through the middle portion of your eye, which is known as the pupil. That is the black hole in the eye. The pupil itself reacts to however much light is in the room. It reacts and acts as a filter to the light you are receiving. So imagine going into a dark room, your pupil gets very large. You go into a very bright room, your pupil shrinks or constricts. The iris itself, after the light has been penetrated through the iris and the pupil, then sends us to the lens. This is the most critical part of seeing. From the anterior chamber's perspective, the lens takes all of that light you just got and sends that to the posterior chamber, which is most of the globe of the eye. Now we enter into the posterior chamber. In the posterior chamber, we mentioned that the retina is housed in this portion of the eye. The retina is the most important part of the eye. Like I said before, this is like the film of a camera. Within this retina is housed microscopic nerve cells. There are two main cells. One is called cones, the other is called rods. Cones are housed within the center of the retina, known as the macula. This is what gives us very sharp vision, gives us color vision, and also helps us see fine detail. The second nerve cell is known as the rods. These rods extend outside the macula all the way to the edge of the retina, known as the ora serrata. I do not expect you to know these at the end of this speech. This is not a quiz. So rods, what do they perform and what do they give us? They allow us to see motion. They allow us to see side vision. They allow us to see in dimly lit areas. Moving on to the next part of this speech is these nerve cells. When they receive light, which we have spoke of so many times already in this speech, they take these light waves and they turn them into electrical impulses. These electrical impulses go to the very part of the eye that is critical communication happens at. This is known as the optic nerve. This optic nerve is the communication pathway from your eye to the brain. Without the optic nerve, we have no communication. We have no way to interval these or to switch these light impulses or waves into electrical impulses. So the optic nerve itself is a very tiny tissue in the eye, and it is very delicate. When it receives these electrical impulses, it tells the brain to convert these electrical impulses in what we know as sight. So all of this happens in split seconds and continues to happen over and over, billions and billions of times in a day. So how do we maintain all of this function in one day? How do we maintain this for the future to see better? To maintain clear vision, we must look at other things that contribute to this. The eye sits in a protective bony socket called the orbit. That orbit houses 6 extraocular muscles. Quickly, we will go over these in the orbit. These muscles move the eye up and down, side to side, and they rotate the eye. The extraocular muscles are attached to the white part of your eye. This is called the sclera. The sclera is a very strong tissue that extends from the front of the clear part of your eye all the way to the back part of your eye. If you were to take the eye out, you would see that it is housed in a completely white capsule, much like your skin is. The surface of the eye and the inner surface of the eyelids are covered in a clear membrane known as the conjunctiva. Some of us have seen people with pink eye. This is called allergic conjunctiva. The importance of the conjunctiva is that it produces a liquid or substance that we know as tears. Tears help us see. They help us give clear vision to the cornea. They help give nutrients to the cornea. Without tear, all of us would see everything very, very fuzzy. Tear is a 3-layer component. It consists of mucus, water, and oil. This important fluid maintains the lubrication of the cornea, allowing clear surface of the light to pass through. But all of this is great, but the one component we haven't talked about is age. As we age, so do our eyes. And so, with aging comes natural eye changes. When we are born, our eyes are in development stage very, very early. Interesting fact is that by 5 months of age, our eye is 2/3 developed. And by age 7, our eye is completely an adult eye. This is information you can get at the American Academy of Ophthalmology. Most vision complications start at about age 40. At age 40, one of the most common things that happen is called presbyopia. Presbyopia is a common early natural aging sign where we start to lose sight up close. We cannot see things at near, cannot read things at near. This is a very common problem as you get older. A second thing that all of us will get if we live long enough is cataracts. Some of us here may have had cataract surgery. So what is cataracts? Cataracts is a common posterior eye disease it's a common anterior eye disease that the flexible lens that you have in there becomes less flexible, it becomes thicker, and it becomes very cloudy, preventing sharp detail and naturally preventing light from penetrating past it to the retina, allowing us to see properly. The third thing that all of us will experience is age-related macular degeneration. Now, in times past, this is something that's happened along as we age, mostly in our 80s or 90s, but now we have seen it in even earlier as age 45. This disease is a posterior eye disease, so it's in the back portion of the eye, and it's housed in the macula, or around the macula, where those sensitive nerve fibers are, those nerve cells, the rods and cones that give us such great detail are housed. This disease can be disabling if not monitored by an eye care professional. This brings up the importance of annual eye exams once a year after the age 40 to detect any normal changes of vision. Other ways to keep eye health are choosing healthy food choices, stop smoking, and continue to monitor systemic health problems such like diabetes, high blood pressure, even thyroid diseases are very important when it comes to eye health. Our vision is precious and our eyes are the portal to the world. Without vision, many of us would many things that we do simply like tying our shoes, eating, brushing our teeth, combing our hair would be absolutely impossible. So give kudos to light that surrounds us every day, and to the precious gift of sight, thank you.